Hello and welcome back. In this video we're going to delve into how we make informative and compelling figures. Now we have already seen how we use the base R functions plot and histogram and box plot and bar plot and rug, etc. in some of our previous videos. Now we call these base R functions because they come pre-installed with R itself. They take typically simple numeric input vectors and produce plots pretty quickly. And I've produced many thousands of scientific visualizations in this way and used them in many publications, but they are tricky to refine and to make just the way you want them, to polish them up, just the final kind of icing on the cake that you want to put on these kinds of figures. So in this video, and indeed in our course going forward, we're going to take a different approach. We're going to focus on a different graphics system for R, one that comes with an add-on package for R called ggplot 2. Now ggplot 2, it's ridiculously popular and it makes beautiful, compelling figures. So we're going to delve into how this works. Before doing that, however, I want to mention two recent books here that I'm basing much of this video content and indeed our course going forward on. These two books, they're available in hard copy here, and I really enjoy reading them this way, but they are also available free online, and that's a big plus. They also have all the R and ggplot2 code used to produce every single figure in the book online, and that's super helpful, and it's a great way to learn and get inspiration for your own visualizations. So please check them out if you're so motivated. Now, a key insight that's really beautifully reviewed in these two recent texts here, but based on a lot of earlier work, is that all data visualizations at their core, they map data into quantifiable aesthetic features of the resulting graphic or figure. So the key points here are the data being mapped to these things called aesthetic features. Now this seems like a bit of a mouthful, and without context, without reading these books here, it's a little bit abstract. So what does it boil down to? Well, it boils down to taking our data, that's our input, and columns from that data typically, that's the information we're interested in conveying, for example, and mapping them or representing them as things we can see, as these things called aesthetic features. So what are these things we can see? What are these aesthetic features? Well, the common ones we're probably used to seeing. There's things like position along a coordinate scale, such as a two-dimensional X and Y plane, or the relative size of a plotting character, perhaps the dot dash pattern of lines or the line width, distinct colors or shapes. These are all common aesthetics that many of us will be used to seeing here. So early on here, and why I'm showing this slide, is that it's very useful to think about what types of data we can map onto these aesthetics. What would be usefully represented by these types of features? So if we have things called continuous values or variables, like varying numbers that change in their magnitude, for example, these will map well onto things like position or size or line width, and also color, as in this example, if we can faithfully alter the properties in a graduated fashion that conveys the data value changes. Then we have a second class of things, of values, of variables, called categorical values, which take one of a defined set of values, like dead or alive, or intron, exon, non-coding, these sorts of things. These data are typically named or labeled, and they're not numeric. They'll map well onto things like line type and shape, and some others that we'll come across a little bit later in the video. And also, I should point out here that color can be used for both the continuous values, as we just saw, and also categorical values. So there's the continuous color kind of scheme or palette, and here's a different one that can convey, that's not conveying this quantitative trend here, but it's really distinct and categorical in nature. So, these continuous value mappings here will depend on the color palette, or our choice of colors that we use for these visualizations, whether we're mapping it to continuous as shown here, or the categorical as shown just a moment ago. So with that data to aesthetic mapping knowledge behind us, let's get started. So please now pause if you haven't already got RStudio open and go and open it up and get it ready to enter in code. We're going to again focus on the R console here in the large panel. That's the R brain where we're going to input our code and type our code out. And then we'll also focus here on the plots panel, the second smaller panel, where our output, our graphics are going to appear once we've entered working code. Okay, so you should have your R console in front of you, and the first thing now we're going to do is we're going to install this ggplot 2 package. Remember, this is an add-on package here for R. It doesn't come installed with R. It's like going to the App Store and getting a new app to allow your phone to do new things. That's the same thing we're going to do here. So we're going to issue this first line, and then in the second line we're going to load up that package so we can use the functions. And in the third line here we're going to take some example data that actually ships with the ggplot 2 package and make sure we've got it. So let's do that together. So here first in my R console I've typed install.packages, this command, and then the name of the package I want to install in quotes or speech marks. In this case it's ggplot 2, and I push return and it goes off and downloads the package and makes it available on my computer. I still can't use the functions from this package until I do the second line. The second line is the library call function here. And what this does is it loads that package into R. And I need to do this every time I want to use the package. Unlike the install.package, the first line, which is a one-off, I only ever need to do it once. Now the code is there on my machine, but every time I want to use the package, I'm going to have to do the second line, library ggplot 2 in this case. That's because every time I use R in the future, I might need or indeed want to use this package, and there's no point in automatically loading it every time and occurring that overhead of doing that. So I'll just call it when I need it, right? So I'll go to the library and get the book when I want to read it, rather than have the book sitting on my desk all the time when I'm not working on that type of material. That's the idea. So once I've done that, the library call, I'll finally enter this third command here. That's the view with a capital V, and then mpg. This function will load this data set that comes with ggplot 2 called mpg, which stands for miles per gallon. And once I push return here, that will bring up this kind of spreadsheet, Excel looking like thing view of the data set here called mpg in this case. So let's zoom in here and make this a little bigger. So what do we have here? Well, we have a listing of, in this case, 234 cars. That's one per row that you can see down here at the bottom. It tells me how many rows I have. I could also use the function nrow or ncall to find out the number of columns. In this case, there's 11 columns of data about each of these cars, including things like the manufacturer, the model name, the engine displacement, the number of cylinders in the engine, the transmission type, whether it's automatic or manual, stick shift, whether it's front wheel drive or four wheel drive or rear wheel drive, and then the fuel efficiency in city driving or highway driving here, for example, and a few other columns that we'll come back to, like the class of the car, whether it's a compact or a pickup or an SUV, these sorts of things. So let's take a look at the relationship between two of these variables, two of these columns here in this data frame to begin with. I'm going to look at engine displacement here, highlighted in red. That's in liters. It's a measure of kind of engine size. And then we'll also look at highway miles per gallon here. That's the second highlighted column here, and that's a measure of fuel efficiency. You'll go more miles for a gallon of fuel here if you're more fuel efficient, for example. Okay, so we'll start by plotting these values and trying to get ggplot to do a representation of these two variables. So what we're going to be using here within the ggplot 2 package is the main function within the package. That's called ggplot simply, and we call it like we call every function, with the name of the function and parenthesis with the inputs inside the parenthesis or the brackets here. Now what it'll take as input is a data frame as input, right? Just like that MPG one that we displayed just a moment ago. So we're going to give that data frame to ggplot as input, but it needs a couple of other things. It also needs a mapping of the column, the variables that we want, in our case the column names in the data frame, that we want to map to which aesthetic features of the visualization we want to produce. Things like the X and Y axis, for example, or the color, or the transparency, the alpha value, etc. And then we also need a third thing. It also wants something, a so-called geometry layer, or geom for short. That is, do you want your plot as points, like in a scatter plot, or lines with geom line, or bars with geom bar, etc. So we're going to take these three things, minimally these three things, the data, the aesthetic mapping, and the geoms, to make our ggplot. Okay, so what this looks like in R, each one of these is a function, of course, and we're going to combine them. We're going to combine them, and this is kind of a peculiar thing that we haven't seen before, but we're going to combine them with a plus sign here. That's the way ggplot wants these to be combined. So I'm using the code here, the ggplot, the data, I'm telling it is the mass per gallon, the aesthetics, I'm mapping X to Y, and then I'm adding on a third layer, this geom point layer. So it really is, in effect, like we're adding layers, okay? So here I'm showing this, we're adding layers to produce our final plot, our data, aesthetics, and our geometry. And when we push return on our code, we'll get our output that appears here in the plots panel of RStudio, and we can see the x-axis down the bottom is mapped to displacement, the y-axis there along the side is mapped to that highway miles per gallon, and we've got these point geometries displayed here for our actual data. So let's look at each of these in turn here. Now the first step, what it does when we call the ggplot and give it our data, it sets up the plot region. It doesn't produce much in the way of interesting output, but you can enter this command in itself and you'll see this kind of blank plot region setup ready for our data to appear in if we add more layers. The next function call here, this aesthetic mapping, what it does is it'll actually, in this case, take our displacement on the x-axis and highway column on the y-axis, but we don't have any data plotted. It sets up the plot, but notice there are no actual data plotted here, because we have to tell R how we want to display that data. Do we want it as lines, do we want it as bars, or do we want it as points? And in this case, we're going to pick points. So we'll add this layer called geom points, and now we'll see our final plot as we had previously. So a side note here, if I go back to that for a second, if you see some ggplot code like this, or more complicated ones with other layers, as we'll see in a second, you can always execute it like this and then start deleting layer by layer to see how the plot works, to see how it's built up in this layer by layer fashion. Let's go on and keep adding another layer to make more complicated plots in this case. So what I'm going to do, for example, here is let's add another layer, another geom layer in this case, for a smooth line that'll be fitted to our data. And I'm adding that with the plus sign again at the end of the line, the previous line. That's important, where we put our plus symbols not at the start of the new line, but at the end of the old line. And we add our geom smooth, and we get this new geometry appearing in our plot. We can also add other customizations in this fashion, like changing the way the plot looks with so-called theme layers here, of which there are many. So this is one that I like. That's a more simple, more traditional kind of display, or black and white theme BW here. Or adding various annotation layers like labels here with a title, a subtitle, and a caption down at the bottom corner of the plot, and some custom axis labels, for example, here. So the key thing here, however, we can keep adding these layers and making more and more complicated plots, layering on this information. But the key thing that I want to emphasize here is that we minimally need these three things: the data, the aesthetic mappings, and the geoms. Okay, so let's look at each of these geoms in some more detail. That's these three geoms: data, aesthetics, and geoms. So the aesthetics, in our example, it was points. That was, the X and Y were mapped to some columns in our data that we provided here in the call to aesthetics. So let's take another column and map it to another aesthetic. Let's pick maybe color first. So here, notice how I do this. I add it along with my X and Y inside this AES, or aesthetic function call. That is, the only difference to the plot and the code that I had before is that I have this color equals, and I pass this other column called class, the class of the automobile, whether it's a pickup truck, a compact, or a subcompact, or a four-wheel drive, SUV type car, whatever. Look at how the plot changed here. What it's done is it's colored up the points by that variable, right? The points are now colored based on the class of the automobile. It's also added this legend, because it's a categorical variable here. It's added this legend shown with these distinct colors for each category. Okay. So the variable I picked there, just so we know we're all on the same page here, it was the class column. So that's this last column here that I'm highlighting. I've already mapped the X and the Y to these other two columns, and now I'm mapping a third column to another aesthetic. It describes again, compact, minivan, pickup, etc. So it's a categorical variable. It's labeled. It's not a continuous numeric variable with some numbers that we're interested in how it changes, for example. And ggplot, under the hood, as we've said, it picks a nice distinct color scheme and adds a legend to help us out as a guide here. So we'll see that we can easily customize all these things, the color schemes, the labels, where they're placed, what they're called, all these things. We'll see that we can easily customize them later. But let's move on and add one more layer here. We're going to add, one more aesthetic mapping. I'm going to map another categorical variable. That's the number of cylinders in the engines, whether it's a V8 or a 4-cylinder or a 5-cylinder or 6-cylinder. And note that this column here, I'm representing it as shape, but it does have numbers in it. If we went back to the table, we'd see that there are numbers like 4, 5, 6, 8. However, I don't want them treated as a continuous variable because, there's no 7-cylinder engine, that just doesn't exist. They're really categories, they're really labels. They're not represented as numeric variables. I want them as categorical variables here, or values. So I use this called factor, or I could use as factor here, to make sure that ggplot does what I want it to do, to represent them as these categories for each cylinder reading. And it's, here, so now what you should see is that I've got two legends, right? I've got this shape where there's a little plus or a square or a triangle or a circle for the different cylinder numbers in these automobiles, as well as the color for the different class of the automobiles, as well as the XY position based upon the highway miles per gallon and the displacement of the engine in liters in this case. But it's kind of getting hard to digest all this information here. So I'm going to try and represent it in a slightly different way, a different approach. A so-called faceting. And what I'm adding here, notice the code up here, it has this thing called facet wrap, another function that I'm adding on, again with the plus symbol. And what this function does, it takes the name of the variable I want to facet by, and it'll, in this case it's cylinder, and ggplot, it'll break it out into a multi-panel plot, one for each level of that categorical variable or factor here. So now I've kind of much more clearly, in my views, we can really see the different sizes and different categories of engines and where they lie in relation to their highway miles per gallon in this case, where the larger engines with the larger displacement that also have the most number of cylinders are also the least fuel efficient in this case. So, we can keep going in this way, adding more aesthetics to add more and more data onto our plots. And in this example here, I'm actually showing 5 different variables mapped into this one plot. So I'm showing, the X and Y, the fuel efficiency and the displacement. I'm showing actually engine size, horsepower. I'm showing weight and the number of cylinders. So there's 5 things. So now, just because I can do this doesn't mean that I always should do this. And again, probably faceting here by one or more indeed of these variables might be a better approach for a viewer to grasp the point we're trying to get across. But it's your choice. You're the person building these plots. So you're going to explore this and add different lines, different layers to explore your data in this kind of iterative fashion that we've been building up. So that was an introduction to using aesthetics. And there are others such as alpha, or for transparency or opacity, that that I've not mentioned, but we'll see in our hands-on session. But what I want to finish off with is a little discussion of these geometry layers, these geomes here. Now, essentially what these functions are, they're all named in similar ways, and we can usefully think of them as creating different plot types, such as geom bar for bar plots, geom histogram for histograms, geom density for density plots, and geom box plot for box plots, etc. So they they will produce different visualizations, different plot styles, if you will. Now, there are over 40 different geoms in the ggplot2 package, and there are many, many others available in other packages, and I'll encourage you to explore some of these. Critically, not all aesthetics work with all geoms. So, for example, here I'm taking geom histogram, and it only needs one x. It doesn't need a y here, right? Because it's going to bin my values of x and produce this kind of histogram. So we don't need a y for this geometry, for example. But of course, it can take many other aesthetics, including fill here to color the bars, the fill of the bars. The color here optionally, it'll break it down into separate histograms. For example, here if I use the group argument here to the aesthetics, like in this example here, geom density is very similar in its purpose, and indeed in the code we use to produce it. Again, only an x is required in the mapping here, not a y in that aesthetic call. Same story here with geom bar and geom call. It's kind of partner in crime for making bar plots here. Again, I'm only using an x value here, and we can of course do the group and the fill and the color. Geom box plot, again, it'll actually take both an x and a y. Here, as in this example, you see this aesthetic call where I'm mapping highway to x, and I'm making sure my cylinder is a factor. So I get a box plot for each one of these cylinders here, and it's organized this way, kind of flipped versus the standard because of the way I specify my x and my y here. As well as other annotation layers it'll take, as we mentioned before, and turning off the guides, for example, turning off the legend. We can all add these as distinct layers. So where do you find this kind of information about the aesthetic mappings and the different geoms? Well, they're the function help pages themselves, but I also really like this cheat sheet here that I've put a link to on our class website. You can also just Google for this ggplot cheat sheet. It's made by RStudio and distributed by RStudio. And I'm going to finish the video here again just to emphasize that you learn this stuff by doing it. So please do turn to the hands-on session for this week and type out the code yourself. Don't just copy and paste it, but do experiment with it. Take off layer by layer of those things that we're using, the code we're using to make these ggplots, to explore how they work and how these visualizations are made up, and experiment. Make your own plots, your own visualizations. Change the aesthetic mappings. So we also have a data camp course on these topics. That's excellent, and I encourage you to pursue that. I'll see you in our live stream when we dig into these things a little bit more, and I'll finish there and see you next time. Thanks for watching.